Secondary alcohols react in several minutes, whereas primary alcohols forms alkyl chlorides only on heating. Whatever you are seeing in the markets as spirit, that methanol will be mixed with ethanol. Power alcohol is used as a motor fuel, that is 80% of petrol plus 20% of ethyl alcohol. Diazonium salt, when treated with water and warmed, it will give phenol and nitrogen gas will be liberated. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Now, I am going to start session 3 from the chapter Alcohols, Phenols and Ethers. In the previous session, we have discussed about methods of preparation of alcohols from alkenes, from carbonyl compounds and from Grignard reagent. And also, we have seen physical and chemical properties of alcohols. In the current session, we will discuss the next kind of reactions involving cleavage of carbon and oxygen bond in alcohols, identification of primary, secondary and tertiary alcohols, properties of methanol, then next what are phenols, classification of phenols, nomenclature and preparation of phenols. These are the contents which we will discuss in the current session. First we will see reactions involving cleavage of carbon and oxygen bond in alcohol. Dehydration of alcohols means the removal of water molecule from alcohols. Okay, alcohols are heated with protic acid such as concentrated H2SO4 or phosphoric acid at 443 Kelvin. Dehydration takes place to form alkenes. Okay, if we remove water molecule by using protic solvent like H2SO4 or phosphoric acid, dehydration takes place and it will form alkene. See here, removal of water molecule can be seen. Example, ethanol undergoes dehydration by heating it with concentrated H2SO4 at 443 Kelvin. This is ethanol. When we use protic solvent like concentrated H2SO4 and heated, it will form ethene and removal of water molecule can be seen. Next, secondary and tertiary alcohols are dehydrated under milder conditions. This is secondary alcohol at 440 Kelvin in the presence of phosphoric acid. Propene will form and with water. Here tertiary butyl alcohol at 358 Kelvin and in the presence of phosphoric acid, 2-methyl propene will form. Thus, the dehydration of different types of alcohols is in the order tertiary alcohol, secondary alcohol and primary alcohols. Mechanism of dehydration of alcohol means how the electron movement will be seen while dehydration of alcohols can be done. Step 1. Formation of protonated alcohol. Alcohol undergoes protonation, gives protonated alcohol. Okay, this is alcohol CH3, CH and OH. Okay, ethanol. If we use acid here, alcohol will undergoes protonation. Okay, see here CH3, CH2. For this OH, this H will be added. Okay, so protonated alcohol or ethyl oxonium ion will be formed. Step 2. Formation of carbocation. Okay, protonated alcohol loses the water molecule to form carbocation. It is the slowest step and hence the rate determining step of the reaction. Whatever here this protonated alcohol has been formed, in that water molecule will be removed and this is the slowest step and will considered as rate determining step and it will form carbocation. Okay, and removal of water molecule. Elimination of proton. So, whatever the carbocation has been formed in step 2, from that removal of or elimination of proton can be seen. When proton has been removed, here double bond will form and ethene will be created. Here elimination of proton. Once again we will see in the step 1 formation of protonated alcohol. This proton will be added for this alcohol. This is a fast reaction and here protonated alcohol can be seen. For that protonated alcohol, in that removal of water molecule can be seen and carbocation will form with the removal of water molecule. When carbocation is formed, in that removal of or elimination of proton, if you see here ethene will formed. Okay, that is how From dehydration of alcohols, alkenes will be produced. Now, identification of primary, secondary and tertiary alcohols by Lucas reagent test. Okay, you have seen so many tests or how to distinguish about primary, secondary and tertiary alcohols in the laboratory. By using Lucas reagent test itself, you can differentiate between these three categories of alcohols. A solution of anhydrous zinc chloride in concentrated hydrochloric acid is called Lucas reagent. Anhydrous zinc chloride in concentrated hydrochloric acid is called Lucas reagent. Lucas reagent is a convenient reagent to differentiate between primary, secondary and tertiary alcohol. Tertiary alcohols react very rapidly to give an insoluble layer of alkyl chloride at room temperature. Means tertiary alcohol react very rapidly and it will be insoluble. Secondary alcohols react in several minutes, whereas primary alcohols forms alkyl chlorides only on heating. Okay. Zinc chloride probably assists in the breaking of the carbon and oxygen bond of the alcohol. Why this zinc chloride is given? Probably it will assist to the breakage of carbon and oxygen bond in the alcohol. The time taken for the appearance of turbidity is different in three types of alcohols, can be used to distinguish primary, secondary and tertiary alcohols. Okay. Lucas reagent, anhydrous zinc chloride plus concentrated HCl. In tertiary alcohol, immediately turbidity can be seen. Okay, that formation of alkyl halide. Here in secondary, turbidity after 5 minutes. And in primary alcohols, turbidity will form only on heating. Based on this turbidity, you can differentiate between tertiary, secondary and primary halides or alcohols. And by dehydrogenation, when the vapors of alcohol are passed over heated copper or silver catalyst at 573 Kelvin, primary alcohols undergo dehydrogenation to form aldehydes. Dehydrogenation means hydrogen will be removed. Here, tertiary alcohol, when treated with copper or silver catalyst, aldehyde will be formed. Ethyl alcohol, same conditions, acetaldehyde will form. See, hydrogen will be removed. Next, secondary alcohols also undergo dehydrogenation to form ketone. This is secondary alcohol treated with copper or silver catalyst, it will form ketone by the removal of hydrogen. Isopropyl alcohol form acetone. Tertiary alcohols undergo dehydrogenation to form corresponding alkene. Okay. Tertiary butyl alcohol in the presence of copper or silver, 2-methyl 2-propene will form in dehydration. Dehydration means removal of complete water molecule only seen. Tertiary alcohols do not undergo dehydrogenation due to the absence of tertiary hydrogen. Only primary and secondary alcohols will undergo with dehydrogenation, but tertiary alcohols will undergo dehydration. It will not undergo dehydrogenation because there is an absence of tertiary hydrogen in that compound. Okay. Next, properties of methanol. Methanol is a colorless liquid. The boiling point of methanol is 337 Kelvin. Methanol is poisonous and ingested can cause blindness or even death. Okay. It is a colorless liquid. It is having boiling point of 337 Kelvin and it is completely poisonous in nature and it may lead to death also. Uses of methanol. Methanol is mixed with ethanol and sold in the market as spirit. Whatever you are seeing in the markets as spirit, that methanol will be mixed with ethanol. Methanol is used as a major solvent for paints and varnishes. It is also used as antifreeze for automobile radiators. It is used for denaturing ethyl alcohol. Methanol is used for making formaldehyde also. It will be used to prepare formaldehyde also. These are the uses of methanol. Next, uses of ethanol. Ethanol is also used in solvent in paint industry and in power alcohol plus traces of benzene. Power alcohol is used as a motor fuel, that is 80% of petrol plus 20% of ethyl alcohol in alcoholic beverages. Next, phenols. In the chapter alcohols, phenols and ethers, Alcohols we have already completed by its nomenclature, classification and distinguish test, and also physical properties and chemical properties. Now we are moving into the next category in this chapter, that is called phenols, another functional group. These are hydroxyl derivatives of aromatic hydrocarbons in which OH group is directly attached to the benzene ring. If this OH group is directly attached to the benzene ring, that category will call it as phenol. If one OH, phenol. If two OH is attached, that is catechol. Phenol is also known as carbolic acid. Okay, name itself will tell it is acid, and they are the hydroxyl group which is directly connected to the benzene ring. Classification of phenols. Based on the number of OH group directly attached to benzene ring, phenols are classified as monohydric, dihydric and trihydric phenols. Okay, based on number of phenols attached to the benzene, it will be classified as monohydric, dihydric and trihydric phenols. In phenols, OH group is attached to sp2 hybridized carbon atom of benzene ring. If you see here, it is also sp2 carbon. For that sp2 carbon, OH is attached. We'll see now monohydric phenols. They contain only one hydroxyl group directly attached to benzene in their structure. If you see any of the compound here, only one single phenol group is attached. OH, here also OH, see here. But this is orthocresol, this is metacresol and this is paracresol as common name. And in IUPAC name, 2-methyl phenol, 3-methyl and 4-methyl phenol. But everywhere only one hydroxyl group is present. Dihydric, these compounds contain two OH groups directly attached to benzene in their structure. Okay, catechol, common name, this is resorcinol and this is quinol at ortho position, at meta position, at para position. In IUPAC name, benzene 1,2-diol, benzene 1,3-diol, benzene 1,4-diol. Okay. Next, trihydric, 3 hydroxyl groups will be attached directly to the benzene in their structure. Pyrogalol, hydroxyquinol, fluoroglucinol, and this is benzene 1,2,3-triol, benzene 1,2,4-triol, benzene 1,3,5-triol. Okay. Nomenclature of phenols. The hydroxy derivative of benzene is phenol. The word phenol is both name of a specific compound of a family of compounds. Substituted phenols are named as either a derivative of phenol or by common names. In common system, ortho, meta, para are used in their names when there is only one other substituent. In common name, as we have already seen, ortho, para, meta will be used. In IUPAC system, the substituted phenols are named as phenol derivatives. When naming compounds as phenol derivatives, the carbon containing OH is always carbon number 1. In IUPAC system, where OH is attached, if no other derivatives are attached there, that carbon will considered as first carbon. If there are 2 or more additional substituents, each must be numbered beginning at the OH group and going in direction that gives substituents lowest numbers. In other substituents also added, OH will be first and going towards the next in the decreasing order. The di and trihydric phenols are named as benzene diols and benzene triols. If it is di or trihydric phenols are there, it should be named as benzene diols or benzene triols respectively. See here, this is phenol, orthocresol and metacresol and paracresol. This one, 1, 2, 3, 4, 5, 6. Okay, first hydroxyl only and next methyl. So 2-methyl phenol and here 1, 2, 3. So 3-methyl phenol and this one you can take it as from this side or this side. We'll take here 1, 2, 3, 4, 4-methyl phenol. Here benzene 1,2-diol, 1, 2. Here also 1, 2, 3, 1,3-diol, 1, 2, 3, 4 benzene 1,4-diol, and here you have to take from OH itself. So 1 you can take 2, 3, 4, 5, 6. Okay, 2, 6 dimethyl phenol. Here 1, 2, 3, benzene 1, 2, 3, triol. Here also 1, 2, 4, triol, and here 1, 3, 5, benzene, triol. Okay. Next, preparation of phenol from benzene via sulfonation. In this process, benzene is converted into benzene sulfonic acid by treating with oleum, that is sulfonation. Then benzene sulfonic acid so formed is converted to sodium phenoxide by heating with molten sodium hydroxide. Acidification of salt gives phenol. This is benzene by treating with oleum, and later benzene sulfonic acid will form and treated with sodium hydroxide and acidified will later gives phenol product. Okay. Next, from diazonium salts. A diazonium salt is formed by treating aromatic primary amine with nitrous acid at 273 to 278 Kelvin. Diazonium salts are hydrolyzed to phenols by warming with water or by treating with dilute acids. This is phenol. When treated with hydrochloric acid and nitrous acid, it will give benzene diazonium chloride, okay, with the liberation of sodium chloride and water. This is a diazonium salt. That diazonium salt, when treated with water and warmed, it will give phenol and nitrogen gas will be liberated. Okay. How that benzene diazonium salt through aniline, how it can be formed? By the oxidation of cumene by air. In this method, cumene means isopropyl benzene is oxidized in the presence of air to cumene hydroperoxide. It is converted to phenol and acetone by treating it with dilute acid. Acetone, a byproduct of this reaction, is also obtained in large quantities in this method. This is cumene when oxidized in the presence of cumene hydroperoxide. It will be converted to cumene hydroperoxide. Later, it is converted to phenol and acetone by treating with dilute acid. Okay, cumene get oxidized with to form cumene hydroperoxide and treated with mild acid or dilute acid, it will form phenol and acetone. This is how the preparation of phenols has been done. In the next session, I will explain about physical properties of phenol and chemical properties of phenol. I hope you have understood whatever I have taught today, that is about alcohols, like some of the reactions and its uses, and also introduction of phenols like nomenclature, classification and preparation of phenols. So, we will meet in the next class. Till that, thank you.